You may have already noticed one of the what's sometimes called a law of exponents. That is to say, we saw this on a couple of them. When we saw x squared times x, this was x cubed. When we took x squared times x squared, this was x to the fourth. There was 2 copies of the x here, 2 copies of the x here. If this was larger numbers, let's say this is x to the fourth times x to the fifth, what would we get there? Well, there's 4 of them there and 5 of them there. There's a total of 9 of them. This first law of exponents, rule for multiplication, whatever you want to call it, is saying exactly that. If we have some number raised to a power, and we multiply that by that same base raised to a different power, possibly different, we can just kind of put them together by adding those exponents and keeping the base the same. You can see this is x to the 9th still. So if we have x squared times x cubed, this would be x to the 5th. 2 plus 3 is 5. We keep the base the same. If we have 3 to the 5th times 3 squared, well, of course we could use this law of exponents. It seems a little silly to use the law of exponents when we're dealing with just straight up numbers here, but let's try it both ways. Let's say 3 to the 7th. Let's ask our calculator what 3 to the 7th is. Let's go 3 to the 7th. 3 to the 7th is 2187. Now, whenever you see one of these rules, it's always a good idea to kind of do a sanity check and make sure that everything is working out. So what I'm going to do is I'm going to independently figure out what 3 to the 5th is and 3 squared. So 3 to the 5th is 243, and 3 squared is 9. So this thing right here I could have written as 243 times 9. And, when we're simplifying things, it better not depend on the way we write it, to get a different number. If we do it a different way, we better get the same answer. And you can see on both of these we got 2187. So ultimately it doesn't matter if I added the exponents together first and then got 2187, or if I did these exponents first and then multiplied them together. But you'll notice one thing I did not do is I did not say that this was 9 to the 7th. This is 3 to the 7th. We need to keep that base the same. That's what this law up here says. There's an a in the base, there's an a in the base, and then when you add the exponents together, it's still an a in the base. Alright, so looking at this one, well, there's additional things going on here because there's 2 and an 8 here that are being multiplied together as well. But 2 times 8 is 16. a to the 6th times a is a to the 7th, and a to the 7th times a to the 5th, well, let me just write it like this. You'll see I'm choosing to write the a as a to the 1st, because as far as this rule is concerned, it's nice to have something written up there, and if you just write a, that's the same as a to the 1st, so I'm just putting it up there. It's just like when you write an x, you could write 1x if you want, but choose not to write it generally. You could have x. X could be 1x, it could be x to the 1st, it could be 1x to the 1st if you wanted. And you could do other things also. You could say divided by 1 and plus 0. We just choose not to write all these extra bits because they don't change the number at all. And unless they're actually doing something, like in this case, we're going to be adding the exponents, which is, we want to see what it is, what the exponent is. So what I would do here is I'd add the exponents. 6 plus 1 plus 5 is 12. We get 16a to the 12th. Alright, m to the 4th times m cubed, m to the 3rd that is. 4 plus 3 is 7, so this is m to the 7th. This one right here, 5 cubed times 5 to the 6th, we could do either way. We could say 5 cubed and 5 to the 6th and do those each independently. I'm going to choose to do it 5 to the 9th because it's fewer things to plug into the calculator. So I'm going to ask my calculator what is 5 to the 9th, and that is, well, some big number. 1,953,000. 1,953,125. On this one, it looks like we have a 4 and a 6. We have a bunch of y's as well. 4 times 6, that's 24, it looks like. Times y to the 4th, times y to the 1st, times y squared. I'm just writing it like this to make things a little easier on this next step so you can see what's going on. 4 plus 1 plus 2 is 7. So we end up with 24y to the 7th.